So I want to welcome everybody to chapter 20, our conversation of chapter 26 from the R for Data Science book for the data science, or for the R data science learning community, or the data science learning community, online learning community, not anymore the R online learning community, but the data science learning community. Today, what we're going to do is what we've kind of done with this group is, instead of going point by point like previous cohorts, we're going to go over the exercises and some solutions to the exercises in chapter 26. And so that's going to be my main intention today. What we're going to do, but before we do that, I'll kind of highlight some of the key points from the chapter, open it up for anybody that has any questions about challenging subjects that they want to dig into. Then we'll get to the exercises and the exercise solutions, and then we'll go from there. So does anybody have any questions or comments before we get started, or anything just in general?
Yeah.
Yeah, cool. All right. So just to kind of, I guess, do the sales pitch for chapter 26 is like, iteration is one of my, I mean, I enjoy a lot of things about R, but I think there's a lot of power that comes from the iteration tools provided by um, the tidyverse, specifically the per package. And this chapter is really focused on some of those tools. My one critique of this chapter is, in the previous edition, it spent a lot more time like walking through the individual functions that were available within per, which was like map, map2, pmap, um, walk, and all the other different variants. I really enjoyed the old rewrite, because it was kind of cool to see all of the different functions that were available. But the rewrite of this chapter really focuses on some of the utility that you can get out of it. So, what are some of the things that you can do, or what are some of the problems you can solve with iteration? And what are some examples of how to solve those common problems? And those common problems that usually come up in data science are modifying multiple columns, reading multiple files, or saving multiple outputs. And so what it really does is, rather than going like, this is what this one function does, here's an example of what it can do, it really focuses on, okay, how can you leverage these tools to solve these common problems that you come across? So it's not really a critique. It's still nice to see these common problems addressed, but I I felt like I was wanting more, because I really did enjoy learning about like map2, and walk, and pmap, and all that stuff. Um, but it does come up here. Some of those concepts come up again. But the one thing that I did really enjoy about this chapter, and that I took away from it, was the use of these newer functions that I haven't seen before, or that I've been kind of playing around with. These include such things as the use of a cross, the use of so cross was one of them. In addition to it, using lambda functions. So rather than explicitly creating a function, rather than using some older syntax that been used to in the past, using the tilde, that was kind of nice to learn about as well. And then, in addition to it, leveraging some of the tooling already has iteration built into it. And so that was really cool to see too, is like, some of these other functions already have tooling, or have iteration built into them, so you don't have to think about them as a user. And so that is a really, really nice convenience. Uh, the last thing before we start digging into like the exercises and solutions that I want to kind of like bring up with this chapter is usually when people think of iteration, they're thinking of like for loops, they're thinking about while loops, especially if you're coming from like a Python background. For loops and while loops, those are pretty common within Python and other programming languages as well. So this is a similar topic, but just using different tooling to do that. I will say that the chapter does mention that when we get to chapter 27, we'll be introduced into that syntax that like base R provides to you to still use those tools for iteration. But the chapter here really advocates for using these tools because of some performance things. And then also the syntax is sometimes a little bit easier to read than some of those like complicated for or while loops and stuff like that. So the tooling's there for pretty standard iteration that people are most commonly used to, but just a different variant of it to address some of the common problems that you would come across in data science. So the last thing is just the abdication piece of why should you learn this? It's mainly because there's just so much power in the ability to do multiple things with this. I will tell you that when I first learned this stuff, my mind was blown. Like I was just like, whoa, I can't believe I can do all of these different things by just doing just some simple iteration. And so I will say that when it comes to like improving productivity, this is one of those like concepts and sets of tools that have increased my productivity exponentially. And so it is worth taking the time to learn and how to leverage these tools to do these things. Simply put, at the end, it says that this is a superpower, and I think that's even like I think it's even more than a superpower. It's awesome. So that's kind of my kind of overview rundown of it, my pitch, and my advocacy for why we should learn this. Were there any challenging topics that anybody came across that they would like to dig into further? So, DJ, Valerie, if you want to keep using the chat, you're welcome to do that. But does anybody want to dig into any like complicated or topics that they found complicated or want to spend more time on?
I don't find anything complicated like while handling with the for loop, but sometimes like there is a keywords like in Python, right? Like country break the conditions. So sometimes if there is an indentation mistake, so the loop will be iterated for like infinite. So sometimes it crash. So that's a mistake I did it in initially, but after that I don't have any problem with the loop. But right now I'm not using any Python loops. I'm using R. Even I'm not using any iteration work in R. But yeah,
Yeah, absolutely. And if I understand like what you're saying was like the ability to write conditionals, right? Or to
yeah,
yeah. And I think that really kind of goes with so it goes really with this concept right here of like how you actually define your functions. So like you can so like when we use across, and again, I think this is where it kind of gets muddied a little bit because and maybe it's just for me, because when I get introduced to like the iteration, when I first got introduced to iteration, it was starting with map. And map was basically you are iterating over a list set of elements and applying a function to it. But that function that you apply to those elements, you can define yourself, right? And so you could use this syntax, function X with your arguments and then build whatever computation you want within that function. And so getting at your question, DJ, is like this definition of this function, you can define it. So you can put conditionals inside of that function. So if you had some like edge cases that you were attempting to address or catch or some type, you certainly could, but you would just have to define those conditionals or those tests or whatever you're doing inside of the function that you have being defined. Um,
okay,
if that makes sense.
yeah.
Um, which brings up a really interesting thing of like how you actually go about defining like the functions that you want to use. So initially, if you already just want to use a function definition that's already in base R or that's already available in another package that you have loaded in during your session, what you can do is you can pass a specification, and this is getting at a cross, right? You take your column specification, you say, I want to use these columns, whatever tidy selection syntax you want to use. This one's just saying columns A through D, apply this function to it, right? And we don't have any additional specification for this. We just want to use, excuse me, out of the box function and apply it to these columns. But we can supply our own anonymous function in this syntax here, right? So like we can go function, give it the argument that we want, and then apply, whatever we want for that computation inside of the function. Um, the shorthand for this is also known as a lambda function, which just uses this like really shorthand syntax, this slash x. All this slash is doing is it's just replacing function with this slash, so it's just a little bit easier to read. But what's really cool is because this is a function, if we didn't want it to be anonymous and we want it to actually be a function, we can write the function definition outside of this and then just plug it in like we normally do. So, um, but yeah, I think this is just really, for me, I think this is just one of those like really neat things that you can do on the fly when you're writing your code, is rather than just creating like a whole other function, if you have just something really simple to do, you can just do like a lambda function here, an anonymous function, and then, it's really succinct and really simple. Now, what becomes the struggle is if this is like if this is more of a complex function, it's probably better to define that function outside of your iteration, give it a good name, and then just call it inside of whatever iteration function you're using, whether that be a cross, map, or so on and so forth. So, like I said, this stuff is it's really cool. So I could talk about this stuff um, for extended periods of time because like there's just so many really neat things that you can do with it. Cool. Any other questions that anybody wants to address or any other things that they found interesting before we start going through some of the exercises? All right, cool. Well, let's jump over to our studio here. So let's go to our studio. Um, how's the how's the text sizing? Is it good? Can you see it? We need to make it bigger, smaller. Good. Okay, I got a thumbs up from DJ, so we should be good to go. Okay, so there's not really a lot of exercises in here. A few of them were a little challenging, but most of them were pretty straightforward. But the first set of questions was focused on like practicing your use of a cross. And the first question here was really focused on the Palmer Penguins data set. We've seen this data set before, so I'm not going to spend too much time discussing it. But basically, if you want to see what Palmer Penguins is, oops, no, I need this data here, which is
Penguins, yeah.
penguins. It's just basically different measurements of different penguins, I think, in Antarctica. I think you can get some more information about it, but you can see all the different columns. We have species, island, bill length, bill depth, so on and so forth. And what the question was asking is doing is saying like, okay, what we want you to do is we want you to count the number of unique values in each column. So what we can do is if we know the names and the ordering of penguins, and we run this and we look at it. Oh, start new session. I don't know why. I think I need to update my RStudio. I don't know why it keeps doing that. Um, library penguins. We know that we have these different columns within it. So we have species, island, bill length, so on and so forth of the penguin. And so what we can do is since we know the ordering of it from species all the way to year, and we want to count all columns, we can summarize, and then we can use a cross here, which is going to be our function to iterate, and we're going to iterate across all of these different columns. And we just use this shorthand syntax to say, start with species, and then do it for island, bill length, all the way to year. And we just call this function called n_distinct, which just counts the distinct number of values within it. We run that and we get this returned and we get the answer to our question, which basically, when you look at the species column, there are 3 unique values within it. Same for island. Bill length is 165, so on and so forth. I think that this answer kind of falls apart with especially some of these integer or of these columns that are of type integer, mainly because they're not like categorical. So there's probably going to be a significantly a lot more numbers. But like for these categorical variables like sex, year, and species and island, those are categorical. So this helps us understand how many unique values in there. So in this, we know there are 3 unique species that were measured, that there were 3 islands that these species were measured on, so on and so forth. So hopefully you're starting to see the value of this, because we quickly answered a complex question with a very simple line of code. So it's just really nice to see like how quickly you can get your answer by just using iteration to say like, I just want to calculate everything for every column, do it, and it's done. So pretty straightforward, but I'll open it up for any questions that people have about what's going on here. All right, cool. Let's move on to MT cars. So this one was kind of interesting. So let's just look at empty cars for people that aren't familiar. It's just a data set of miles per gallon and different characteristics of various cars within this data set. So the question asks us to calculate the mean of every column in empty cars. So I thought this might have been a little bit of a gotcha question. Well, or there's something here to consider with iteration. So when you think about iteration, what iteration is going to do is it's going to take every single column in order. So miles per gallon, cylinder, displacement, da 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 da. So at first, we could use a cross and we can use that syntax that we were using before. But doing this is going to lean on the structure of the data. We are benefited from the fact that this data set, after the car model, which is of type character, they're all doubles, they're all numeric. And so using this works only in the case because every single column, step by step, is a measurement or is of type numeric. So it works in this case. And then there you go. And what we're doing is we're taking the mean. We're going to use this lambda syntax. The reason why we're going to use this lambda syntax is because I say lambda, it's also known as anonymous. I keep throwing those names around. Is because I also want to pass this additional argument into mean. So if I want to pass this additional argument, the book suggested that you use this anonymous function syntax, because then you can explicitly write out the function that you want to use. So that's because I want to pass na.rm. I'm not sure if there's any missing values in here. I can't remember if there were. I don't think there are. I think MT cars is a complete data set, which it looks like it is. I mean, we can answer that question really easily using iteration, which we probably could do right now, but just for the sake of time, I'm not going to do it. But yeah, that's the reason why we have to do this, or that I think you should do this, because data sets that you usually work with, you're probably going to have missing values. So if you want to do that with this argument, you have to use this anonymous function. But this is leaning on the structure of the data. If we want to be more explicit, to say like, okay, I only want to calculate the mean for numeric variables, right? Because we can't calculate a mean of text data. Doesn't really matter for this data set, because well, actually it kind of does, because, and actually maybe I just fell into a trap myself, because cylinder, VS, AM, gear, and carb are not necessarily a measurement or a numeric measurement. They're just like a categorical, but represented using a numeric. So I might have
Yeah.
actually failed myself here a little bit. Go ahead, DJ.
No, yeah, that's what I was thinking. Yeah.
You're right. I fell into my own trap here. Okay, so instead, let's fix this. So what we can do is we can do displacement and quarter seconds. USEC. Aha. So I think I actually failed the test on this one, because I was supposed to actually do those ones, because those other variables aren't technically a numeric variable. They're just represented using a numeric. They're categorical represented using a numeric. So, interesting. So actually, this is the right way to do it. I guess this goes with the point with this one as well. I mean, this isn't the right answer. I think this is actually the right answer now. But you can see this variation of using where if you did want to use some type of conditional to say, I only want the mean value for numeric or columns that are of type numeric. But in our case, this isn't right because some of these numeric columns are not a true or a value that we could actually calculate a mean. So that's interesting. Any other additional questions or thoughts about this exercise from the chapter? Cool. All right, so let's go to this one. This one kind of tripped me up a little bit. Took me a second to kind of think about it. So what we're going to do is we're going to group diamonds by cut, clarity, and color, and then count the number of observations and compute the mean of each numeric variable. And so this is how I approached it first. Excuse me, is I did a group by for cut, clarity, color. I summarized it, which is nice because we can start with just n, so count the number of rows for our group by. So for each cut, clarity, and color, count up the number of observations. And then we're going to use that where variation to say, okay, I only want to calculate the mean for variables that are of type double. You could change this to numeric if you wanted to, which I probably should because it would be more inclusive, especially if it's like an integer value, which heck, let's just do it because that might help. I don't know if there's any integer data in diamonds. I can double check. I go glimpse diamonds. There we go. Oh, there are some integers. So price is integer.
Price.
Yep. Okay. So numeric is more inclusive. So I should have done is.numeric rather than is.double. But anyways, now we have that fixed, but we're using this where clause as a conditional. We're going to calculate the mean for it. I'm starting to think if I did this correctly because I may want to include NA that is true. So I don't know if I didn't run into any issues, but if I wanted to be explicit to not calculate or to not use any missing values, I could go mean x, comma, na.rm equals true. Let's be a little bit more explicit to say, just in case there were any missing values. But we run this, we take a look at it. There's our calculations for the mean caret, the mean depth, the mean table, mean price for all these numeric variables for the different cuts, the different clarity, and the different color. And in addition to it, we have how many observations are included within this. So we would know that this mean value is based on 4 observations, while this mean is based on 53 observations, right? So, which is really kind of nice. I was kind of playing around with this. I was also thinking like, okay, this is nice for like calculating one thing, but usually when you calculate a mean, you also want some additional measures of spread. And so I was like, okay, well, what
Yep.
about if I wanted to include standard deviation? Well, if I'm going to do that, I have to do some type of list variation where what I can do is all this is the same, diamonds, group by, summarize, count up the number of observations. I just use where and I say numeric variables, anything that's numeric, but I want to calculate 2 different measurements. I want to calculate mean and I want to calculate standard deviation. I have to do this because I have to include this within a list because I'm doing 2 calculations now. And so I want to iterate each column, but I want to iterate each column by calculating a mean for that column and a standard deviation for that column. And to make it explicit when it goes to the output, which is going to get to our next question, I want to make sure that I give it a name. So if I run this, and this wasn't part of the question, I just was playing around with it because I was like, oh, can I do this? And you can. So you have all of these, you have the cut, clarity, color, how many observations are there. You have the caret mean. So here's the mean value. And then you also have the calculation of caret standard deviation. You have the depth mean, depth standard deviation, so on and so forth. So This is a really nice feature. So if you had some additional things that you wanted to calculate, you just add them to the list. Um, I don't want to spend too much time on this, but what's really interesting about this is that this is a list of functions. And this gets at something that's really an interesting thing about R, that everything in R is an object and functions are objects. And so because they are objects, you can include them within a list. And I think that is such a neat thing about R is that we can take these objects called functions and put them in a list and iterate using those functions, which is really,
Yeah.
really kind of a neat idea. Um, I don't know. It's just one of those things when I saw this and I learned this for the first time, it just like blows your mind. I will say like if this is interesting to you, definitely read Advanced R because there's some really cool things that you can create leveraging this, like the concept of function factories, some additional iteration stuff, just some really cool things that come with this like characteristic of R and using functions as objects. But this is just touching the tip of the iceberg for what's possible. So it's a really cool and neat concept. Um, okay. So let's go to this next one. And this one kind of goes with the previous one is it asks like what happens if you do pass a list of functions into a cross but don't name them? How's the output named? Just basically uses the function index. So kind of doing the same thing but without the group by. If you do this on the diamonds data set, it's just going to give you an index value. So index caret one, caret two, depth one, depth two. This one and two represent like mean standard deviation. So the reason that this is happening is because we didn't give each element within this list a name like we did up here. So mean name, standard deviation name, it uses those to actually name the actual columns. So I think the lesson here is just like you can do this, um, but you're not being very explicit. And so you're kind of you're kind of flying fast here if you're doing stuff like this because your output is not going to be named or it's not going to be named in a way that's going to be very explicit and so you're going to have to know what is one and two. And so what I think this question is trying to get at is like, hey, if you are going to use this, give your elements a name. So yeah, you're kind of flying fast and loose if you're kind of doing this. But hey, it might work for somebody, but for me, I would leverage to be explicit in this case. So does anybody have any questions about this? Or what questions
Mm,
can I answer about it? All right, cool. So yeah, I just made that note to myself. So it's likely best to name the functions within the list or use some type of glue specification. So I guess what's also nice if you really wanted to, you could use some glue specification to hyper customize your actual naming of your columns if you wanted to. So okay, so let's do the expand dates. Basically, the question is adjust expand dates to automatically remove the date columns after they've been expanded. So initially in the book, we get this data set called BF date. Boom. You can take a look at it here. It's just a person's name, and then I think it's their birth date. I'm not sure. I can't remember. But anyways, you have your date. Um, what it tries to do is at first, I guess I probably should have included expand dates in here. Um, let me find it. Let me go find it. I'm gonna scroll y'all to death here. Anyways, what it was trying to do is expand dates initially in the book, the function it was trying to just split this date into year, month, day. But as a result of it, it would retain the date column. And the question is basically asking you to only return the year, month, day, excluding the year column. And so when I was thinking about doing this, I first kind of thought this like this would be like there's like a lazy way to do this, or also known as like a less explicit way, where I think what you can do is you can use the dot keep argument and mutate to say just remove any of the unused columns within this data set. And so here's the expand dates. If I run this, so we do expand dates on our data set here, you will still get the date year, date month, and date day. And what it does is it retains the name because name was technically unused. Date was the only column that was used. So since we use this kind of like argument dot keep, it just gets rid of that column. Don't know if that's what it was intending us to do, but I was like, oh, this is kind of the lazy way to do it. But what I think what the book was trying to get us to do was to use embrace. So what it was trying to get us to do was to say, okay, take date var, split it up into year, month, day, and then what we could do is we could use select to eliminate that date var. Because what I do here is I expand the function interface to include another additional argument called date var. So if you put date var in here, it will go in across, split it into year, month, day, and then it will get rid of that date var when you're completed. So I think that's what this chapter was trying to get at, but I also thought this was just kind of the lazy way to do it. Maybe it's not lazy. I don't know. Lazy might not be the right term. Maybe clever or smart way to do it is probably a better way to say it, but not necessarily sure. But the only limitation with this is that it will. So like this is a really simple data set, DF date. If you had additional columns, it would retain those columns. So you have to keep that in. It only works in this case because we only have this one column that's unnamed, or not unnamed, but unused, and it retains it. But if you had additional columns that you wanted to get rid of, you potentially would retain those columns and you would just have to do select anyways at the end of it. So, but what questions do people have about this one, about expand dates or expand dates to, and how I kind of approached solving this problem? Any questions? All right, cool. Let's see, what's the next question? Okay, explain what each step of the pipeline in this function does. What special feature of where are you taking advantage of? So I thought this one was really interesting, and I might actually take this function. So basically the function name is show missing. Inside of this function, there is 3 arguments. The only argument that has a default value would be these summary bars, which is this tidy select. I think they call them verbs. Tidy select verb, which is everything, which in the tidy selection syntax basically says like take every column. Okay. So we kick off, first initial part of this function is just take the data frame that gets passed into the function. We're going to group by, but with this function here, or with this part of it, it's going to use the pick function, which is saying, okay, take the group bars from what was inputted into the function, but make it extendable to multiple columns if you want to. So pick basically is just like modifying group by to say like you can use one column. Well, you could use no columns too, but you can use no columns, or you can use as many columns as the user wants to specify, the user of your function wants to specify. Then we get into summarize. Summarize basically is just using a cross again. We'll just talk about the function here. It's using an anonymous function to count up the number of missing values in that column. And we're using summary bars, which has that default value of everything. So if we just didn't pass any column names into it, we would say give it every single column. So calculate the missing are the number of missing values within the column, whether that be you're explicit with it or all the columns. Drop the groups, which makes sense. And then this last part, which is select, where it's using this where modifier to say any greater than 0. So what select is doing with this kind of where conditional is it's iterating over all of the columns, and it's saying if the columns return anything greater than 0, retain it in the output. If it has 0, don't retain it. So basically what it's saying is only return the columns that have any number of missing values. So it's just taking advantage of the fact that select works on columns, and that it's saying like, okay, if you have a conditional where a column actually has a missing value, return that estimate of what it is. And so what it does here is it takes this NYC flights data, and then it just shows the missing values for so I have to think through here. So here's the data frame. So it's DF. That's the first argument. The second argument would be grouping by year, month, day. And then we just use the default value of everything. And then we run this. Oops, could not find function show missing. Oh, I forgot to specify show missing. So let me run this and look at it. So there you go. So now we have our group variables by year, month, day. We have how many missing values are in each column. And if there aren't any missing values, it would just drop the column. So I didn't dig too much to see if any columns were dropped, which I think there were. Well, it's actually, I can confirm that. So it started initially with 9 columns. It does, because there is 19 columns. What we can do is we can use this function. It drops it down to 9. So 6, is it all of them? So 6, right? So summary vars, so everything. I guess the question I would have is if it's grouping by year, month, day, would it still eliminate? No, it wouldn't, because it would retain year, month, day. So this is the same. So what I'm asking my question would be is like if year, month, day had a missing value and it would it drop? But I don't think so, because it's, well, no, we're dropping it though. We're dropping the groups in them. So this is a good my question would be is like if there was a missing value in year, month, day, would select drop it if it did? I think it would, wouldn't it?
Yeah. Yeah. I mean, you specify the condition, right? Yeah. It
Yeah,
might.
right. Like this is everything because it's saying where, select where, because this is going through all of it.
Yeah.
So, and it's not retaining the groups. So yeah, if year, month, day did have a missing value, then it would drop it. So why is it returning it though? Select where. So is this telling me that year, month, and day do have missing values? That's what I'm asking. And that's interesting. So year, month, day. I mean, we can answer that with some iteration. We could go flights. I don't know what we gotta do. You see what I'm saying? That's my question,
Yeah.
is because like it's returning year, month, day. So does that mean year, month, day also has missing values? Well, no, because we are summarizing. Well, no, okay, I'm getting mixed up because if it did a group by summarize, it shouldn't retain it because it shouldn't retain those missing values because we're still just doing a group by summarize here. So there shouldn't be any missing values in here because it's still going to group it by values that are within year, month, day. So the result of this group by summarize should be a complete set of columns. So then when it reaches this select kind of conditional, it should still be good, I'm assuming, right?
Yeah. I think so. Yeah.
Hmm. Okay. I think that's true. I don't know. If anybody else can answer that question, I'm sure we could like dig through the logic of it and see. Um, but I would assume that it is because the group by summarize would result in complete values. And so there wouldn't be any missing values in year, month, day. But okay. Well, maybe I'm just confusing myself and I'm overthinking it. Um, but cool. Any questions about show missing? No? All right, cool.
No, yeah.
Um, so this exercise wasn't in, well, it's not in the actual book itself, but there's like a hidden exercise that I came across when I was reading the source of the chapter that they didn't include into it, which is unfortunate because I think this is a really interesting question. That iteration is another example of how iteration can be really, really powerful, especially for outputting um, multiple outputs. And so I was like, I'm just going to tackle this one and talk about it during the group because it's a really interesting question. And I was like, this is something that I kind of run into sometimes that I need to do. So let's talk about it and I'll kind of show like how I actually solved that problem. If you didn't catch this, like don't worry about it. It's just me coming across it and seeing it and being like, oh, this is cool. I want to solve this. Um, so the question basically is this: imagine you have a table of student data containing, amongst other variables, school name and student ID. And so what it wants you to do is it wants you to sketch out some code that you would write to save all this information for each student in a file called studentid.csv. So we're just writing a CSV file. But what's interesting about this is the exercise is asking you to not only split it out by student ID, but to split it up by individual schools. So what I decided to do is to kind of create my own little fake data set of students where you have three different schools, you have a student ID, you have their grade for two different classes. Okay, so you run that. If you look at data students, it's just a tibble, same thing, four columns, school name, school ID, grade biology, grade history. And what we want to do is we want to give each student its own CSV file, but we want to store that CSV file in its own school directory. So I was like, okay, let's see if we can solve this with iteration. So the book kind of talks about this on outputting CSVs, but what makes this challenging is now we need to include a directory. So what I decided to do is follow along with the book and initially use this function called group nest. And what I'm going to do here is I'm going to take data students and I'm going to group it by school name and student ID. And so if I do that, what it's going to do is it's going to create this kind of nested data for each student in this data kind of column. Okay. So what I'm going to do now is I am going to mutate another column into this tibble because we're just still working with the tibble here. And I'm going to create a directory column and I'm going to create a file path column. And all this is doing is it's just creating a character or string value with, well, I first have to start off with like this student grades um, directory because I'm going to dump it here into the book directory here. So I'll show this here in a second. Um, and what I'm going to do is I'm going to use the columns within the tibble, so school name to create the initial directory for the school. But then I'm going to create a full file path with the school name, student, individual student ID with their individual grades within them. So if I run this, all this is going to return is just a tibble with information that we can use to leverage using some of the iteration tools that we talked about. So here's the directory column. We have student grades central, and then we have the file path, which is student grades central, student one CSV. So by the end of it, these are the complete file paths of where our CSV files should be dumped. Okay. So my first initial approach at this was using 2 steps. First of them was to do walk and walk 2. So the first issue that I ran into is I first thought that you could just write CSV and write into a directory that wasn't created. That's not the case. At least I couldn't find it if there is a way for write CSV to actually write a directory being a folder, and then the file, it would throw an error. So what I had to do was initially I had to say, okay, let's take the distinct output, which is student grade central, student grades east, student grade north. And the first step was to leverage some tools from this package called FS, which FS, if you haven't ran into before, it just helps you work with your file system. So it's just a ability to help you create files, directories, links, and list different things. So I like FS because it's a really nice set of like functions to help you work with like your system files and your directories. So that's my first step, is just to create those directories. So I walk it, which I think I've already done. I'll output directory create. I have to do FS, so I'm just going to create the directory. Then the next step is to use walk 2. And the reason because we're using walk 2 is because we're putting in 2 inputs into write CSV. And so we're taking the data column. So the data column, so each individual student's grades. And we're taking the second one, which is the file path. So this one here, so central, da 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 da, and then we're just writing the CSV. So when we write this in the second step, what you'll get is if we scroll down here into our file explorer, we now have this student grades directory folder. Click into it, we have central, east, and north. And if we go into here, we'll have our student, and then if you open up that file, their individual grades will be within it. So that's the first way I thought about doing it. So that's like the 2-step way. Before I talk about kind of a more concise way to do it, or to do it in 1 step, what questions do people have about using walk and walk 2?
Yeah, I'm just seeing that thing, the first package. So yeah,
I think the other thing to highlight with this that's really important and kind of is really important, and the book kind of highlights it, is like walk. The reason why I use walk here is because of its side effect. It doesn't create an object in an R session. It creates a side effect outside of our session. The side effect being create the directory or write a file. So that's why I use walk here. We don't need to use, well, maps not really talked about too much in the chapter, but that's the reason why we don't have to use those like per functions, because we're not outputting any object. We're only using it for a side effect. The side effect being to write that directory or write the CSV file. The other big concept here is what happens if you want to pass in 2 vectors of things. That's where you start using this 2 variation. So walk 2, when you start reading more about map, there's a map 2, so on and so forth. But those are kind of the 2 important concepts here. I'm going to delete this directory because I want to do this again, but show you in 1 step. So student grades is deleted. So this isn't really talked about in the book, which I think, because in the initial first edition, it used to talk about the p variances of p map and p walk. So in the per package, and you'll have to read more about this, the reason why it goes from like walk to walk 2 to p walk is like, what if you have a ton of different like things you want to pass into your iteration, 5 or 6, 7 or 8, whatever, as many as you want. So if you want to do this variation, it doesn't make sense to do like a walk 2, walk 3, walk 4, walk 5, because how many different function variations are you going to have? So what it has is it has these p variations in it that allow you to extend how many ever um, amount of objects you want to put into it. In our case, if I want to do this in one step, what I can do is I can pass in these three different elements from our output tibble. So 1, 2, 3, because technically there's not a walk 3. But to do this, I have to pass it into a list. So I have to store this vector into a list, this vector into a list, this vector into this list. So now we have three elements. Then what we have to do is we have to define some type of anonymous function. You can give this function a name if you want to by, refactoring this to put this outside of it and name the function, whatever. But just as a shorthand, I decided just to do a anonymous function. I have to give it some arguments. So this one right here is data. This one is called directory, and this one is called file path. And now what I can do is inside the scope of this anonymous function, I can start referring to these arguments. So if I want to create these directories, I can go dir for directory. So whatever vector name is here. And then my right CSV is going to use this data and then this file path. And so if you run this, you can do it all in one step using pwalk. And to show you that I am being truthful, you have student grades here. You open student grades, you have central, east, and north, and you have all of your student grades. And so you can do all of this in one step by using pwalk rather than walk or walk 2. Okay. And I can show you this is the truth again by using this drls to kind of list out all the different files that are in there. So it's unfortunate that they didn't include this, but I think they didn't include this because they really didn't talk too much about like the p variants of the different iteration functions. But I think that's a limitation of this chapter because it was kind of confusing in the first edition of the book, but it's kind of interesting to see that these are available. But so does anybody have any questions about this approach to solving this exercise?
No.
Pwalk takes so like I said, like pmap and pwalk, they take a little bit to wrap your mind around. But once you kind of learn how they work, it is pretty beneficial because there are times that you want to pass in more than two different elements, or you want to iterate over two different elements by applying a function or whatever function definition you want. So it does come up a few times. So if you want to like get more advanced into it, look into the p variations of like map and walk and stuff. So all right, cool. Any other questions before we wrap up our conversation today of iteration? Nothing
I don't
else?
have any question. No, I was just looking at the pwalk thing only. So yeah.
Yeah, and there's if I remember right, and I'm looking it up right now. If you go to, is it functionals? Yeah, functionals. So if you want to know more about those specific variants of how this works, I highly suggest checking out the functionals chapter from Advanced R. I know it says Advanced R, and there certainly are advanced topics in Advanced R, but if you want to go a little bit further to learn about all of those different variants and some that don't, I didn't even talk about today, like reduce, or even like the concept of predicate function and so on and so forth. Advanced R, the chapter of functionals is a really good chapter to go check out. So, all right, cool. Well, if there's nothing else, I think that's pretty much all we had to cover today. So, oh, no specific questions on my side, but this has been super helpful and given lots to explore. Yeah, there certainly is a lot to explore with all the different per variations. And like I said, if you had me to name like the top three packages that I like in the Tidyverse, Fur would be up there. It would maybe be like the one or two. Well, yeah, it's up there. It'd be one or two. So I highly suggest learning it as much as you can because the utility of it is just quite amazing. I actually get a lot of I get a lot of traction like if I have to output like a lot of like visualizations, there's a lot of like utility in being able to output like objects, a lot of objects. And so um that's really nice. And so just learning a few of these things can be very helpful. So all right, cool. Well, if there's anything else, I'm just gonna hit the stop here and yeah, I guess we'll see everybody next week. If nobody signed up for the base R thing, I'll take it. But I hope somebody can take it. But if not, I will take it, and we will look at seeing everybody next week. So, all
See.
right, see ya.